Hi everyone, in today's lesson we're going to talk about undefined fractions and simplifying rational equations or expressions. A rational expression, rational really just means fraction. So anytime I say the word rational, I want everyone to write down fraction because that's what I mean. A rational expression is undefined when the denominator is equal to 0. Just the denominator. So again, a rational expression is undefined when the denominator equals 0. So what I want you to do is find the values that make the fraction or function undefined. So if you look at just the denominator here, clearly for x, the only thing that's going to make it undefined is when x is equal to 0. X could be 1, x could be 2, even -3, -4. As long as it's not 0, then we're good to go. Let's look at the second example, x plus 4. Now, some of you can do this in your head. Some of you are going to say, well, if x is -4, I know that -4 plus 4 is 0. So some of you are going to go straight to the answer. And that answer is when x is equal to -4, this whole entire denominator is undefined. Same thing for this one. Some of you are going to say, well, x has to be 4, because when I do 4 minus 4, I get 0. Okay, now even this last one some of you can do in your head. You're probably thinking, well, what number squared minus 4 gives me 0? So we know this thing has to be 4 to get 4 minus 4. So what do I have to square to get 4? You're probably thinking 2. But did you remember -2? Plus or minus. So sometimes they're going to get progressively harder, and you're not going to be able to do them in your head. So the rule is set the denominator equal to 0 and solve. So, for example, this one where it was plus or minus 2, we would just set the denominator, x squared minus 4 equal to 0. And we would solve. So what we would do is factor by dots, x plus 2, x minus 2, and then just make a quick little t-chart, and we'll get our -2 and our +2. So let's try a little bit more harder examples. So I see the first one I just did, but how about number 2? I mean, there's no way by looking at this thing that I'm going to be able to figure out what y value makes this 0. But what I know I can do is set the denominator equal to 0, and I can factor. So I know the first step of factoring is to take out a greatest common factor. So I could take out a 2, and I could also take out a y. So I would be left with y squared minus y minus 2. And still equal to 0. And I can factor, figuring out what numbers add to a -1 that multiply to -2. So we have 2y, y, and y. And I think you could do -2 and +1. So now I'm going to set each of these three pieces equal to 0. So 2y equals 0, divide by 2, and I'd get y equals 0. For the middle term, I'll get y equals 2. And for the last one, I'll get y equals -1. So these 1, 2, 3 values, if I plug them in here, I will get 0. So let's just try one of them just to see. So I'm going to plug in -1. I'm just going to plug it into this denominator here. So 2, -1 to the third, minus 2, -1 squared, minus 4 times -1. So take a minute, plug this whole thing, just the way you see it, into the calculator, and see if you do, in fact, get 0. And then hit resume when you're ready. Okay, yeah, you definitely should have gotten 0. So that works. It's undefined. All three of these numbers would work the same. Okay, now the question is also asking to simplify the expression. So this was the undefined piece. So if you even want to write that down, undefined when y is equal to -1, 0, and 2. Okay, so now let's talk about simplifying this piece. Now I'm going to use this space over here because I already did it up here. We are going to simplify the expression, and that actually requires factoring. So I'm going to just rewrite it so that I can simplify it. 8y to the third minus 16y squared over 2y to the third minus 2y squared minus 4y. Now, simplifying these expressions aren't as bad as you think they are. All you have to do is factor. So we're going to factor the top, and we're going to factor the bottom, and cross out anything that's the same. So I already factored the bottom when I set it equal to 0. So these three pieces right here are my factors of this. So I basically can cross this off and write down its factors instead, which are 2y, y minus 2, and y plus 1. Now what I'm going to do is factor the numerator. So I know the first step of factoring is GCF. So it looks as though that I could take out an 8y squared. So I'm going to write that on the top here, just for purposes of room, 8y squared. And I'd be left with y minus 2. So I can't factor the inside anymore. That's just factoring by GCF. So now the fun part goes where I can cross off any top with any bottom. So I can cross off the y minus 2 with the y minus 2. And I can cross off actually this y squared, one of the y's, with this y. And I can actually divide 8 and 2. They're both divisible by 2. So I can turn this into a 4 and that into a 1. So now all that's left is we multiply what's left on top. So what's left on top is 4y, and what's left on bottom is just a y plus 1. So 4y, and then y plus 1. This is my simplified answer. Okay, great. Let's look at the next two examples. Okay, so I'm actually going to factor the denominator because I know that I have to set this equal to 0 to figure out the undefined values. So it looks as though I could take out a 3x, and I'm left with x squared plus 3x minus 10. And I'm going to factor the inside a little bit more using my add and multiplying trick. So the factors of 10 that are going to add to 3. So I think I can use x plus 5 and x minus 2 and a 3x in front. So my values that make this thing undefined are -5, positive 2, and again set 3x equal to 0, so x is equal to 0. Okay, now the numerator. Well, actually, let's write down about undefined values. So undefined when x is equal to -5, 0, and 2. So now if I want to simplify the fraction, I just have to factor that numerator out a little bit. So that numerator is taking out a GCF of -1 will help us. So we have x squared plus 2x minus 8. Now the factors of -8 that are going to add to 2 are x plus 4 and x minus 2, and then with the -1 out front. So if you want to write out the factored form, this is the numerator, and this is the denominator. 3x, x plus 5, and x minus 2. So it looks as though the only things I can cross off are the x minus 2's. So my final answer is nothing other than negative x plus 4 over 3x, x plus 5. Now, you could totally leave it like this. You don't have to distribute anything. And that's it. That's my simplified answer. Okay, let's look at example number 4. All right, so we want to set the denominator equal to 0 to find those undefined values. So we're going to do that first. And let's find these factors. Y. Okay, how about a -3 and a -6? And, -3 and a -2. Okay, so my factors, or my answers, are +3 and +2. So we can say undefined when x equals, or y equals rather, 2 and 3. Okay, so now if we want to factor or simplify this, I'm just going to write the numerator, y minus 2, over its factors, y minus 3, y minus 2. Okay, so now these y minus 2's cancel. But when I say they cancel, when I divide anything by itself, the answer is 1. Now, it's very important that you put that 1 here right now because there's nothing on top. So some people might think the answer is y minus 3, but the answer is actually 1 over y minus 3. So don't forget to put that 1 if there's nothing left on top. Now, I kind of want to talk about a different scenario here. What if the problem said 2 minus y over y minus 3, y minus 2? You actually can still cancel this top out with this bottom, but because they're opposites, they divide out to a -1. So this answer would be -1 over y minus 3. Okay? Now, to prove that, pick any number you want for y. I don't know, let's just say I pick y as 7. And I plug it into this numerator, 2 minus 7, and then 7 minus 2. So the question really is y minus 2 and 2 minus y. Why does that equal a -1? So let's put a number in for y. So say I put 7. What's 7 minus 2? You should be telling me 5. And then what if I put 7 here? What's 2 minus 7? You should be telling me -5. And when I divide 5 and -5, I'll get 1. Excuse me, -1. What happens if I put a different number in for y? Let's say I pick 10. What's 10 minus 2 versus 2 minus 10? Well, 10 minus 2 is 8. 2 minus 10 is -8. That still cancels to a -1. So this is the reason why for any value of y, or any value for whatever variable, if you have opposites and they're set by subtraction, the answer is -1. Now how about addition? What if I had y plus 2 over 2 plus y? What happens? Well, let's try 7 again. 7 plus 2 over 2 plus 7. I get 9 over 9, which equals 1. Okay. How about if I do 10, like I did before? 10 plus 2 over 2 plus 10. So 12 over 12 still equals 1. So if I have addition, it won't matter. The answer is still a +1. And if I have subtraction, it's negative. So what does this tell us? This tells us that the commutative property of addition is true. Commutative property of addition holds true, but the commutative property for subtraction is not true. All right, I know I didn't include this in the video sheet, so what I would do if I were you right now is I would pause the video, take out a piece of paper, write all this stuff down, and then hit resume when you're finished for the rest of the video. Okay, so let's move on to the last page. So what I want you to do for homework is do these 4 questions, and we will go over them in class tomorrow. So questions numbers 1 through 4 are for homework, and I will be checking them. All right? Thanks so much. Have a good night.